All right, we've got some multiple choice problems on differential equations. Let me move this over and I'll go ahead and get started. First three problems here. We have a differential equation where k is a constant and they're telling us that y equals 2 and x equals 1. So that's our initial condition, the point 1, 2. And then they're also giving us another initial condition of the point E4. Then they're asking us to find the y value when x equals 2. So I think the easiest way to do this is to separate, integrate, and solve. And really, all we have to do is multiply both sides of the equation by dx, because this actually is something that we can deal with. We don't even have to separate. Now that I'm looking at it, this is just a straight up integration problem. So if we just integrate both sides of this equation, we end up getting that y equals k times the natural log of the absolute value of x. And if I plug in the point 1, 2, for example, oops, sorry, I forgot my plus c. I need my plus c here. If I plug in the point 1, 2, I'm going to get out that 2 equals k times the ln of 1, which is 0. So I know my c value is 2. So I'm going to go plop that in over here. My c value is 2. Now I'm going to plug in my second point where I get that the ln of e times k plus 2 equals 4. The ln of e is 1, so this expression here just goes to k. So 4 equals k plus 2, and k equals 2. So that goes in right here, and I end up with an answer. I have my equation, and now they want me to actually plug in x equals 2 to find out what the y value is. So y equals 2 natural log of 2 plus 2. And of course, you can use properties of log to bring up that exponent, and you end up with the ln of 4 plus 2, which is e. All right, next one. Solution curve of y prime equals y. Well, there's only one equation where the derivative equals the function itself, and that is e to the x. So that way we know that y equals e to the x, I should say, because we need effectively our plus c, but it'll be an a in front this time. So looking at that, the only one that will hold, oh wait, and then we need to plug in the 0.23. I was going to say the only ones that could be are c and e, because it's not a square root. We're not adding a plus c, and we are not adding a plus c. So if I plug in the 0.23 and I solve it, I am going to get c as my answer. And I'm doing that off of the top of my head, but I think 3 divided by e squared, which is 8 point something, will get me this 0.406. Okay, last problem says solution curve has been superimposed on the slope field. The solution is for the differential equation with what initial condition? So here's the interesting thing. The solution curve certainly looks to be tangent, okay? But which one of these would integrate to tangent? It's not the first one, because the first one effectively says that the derivative is tangent. And that is not what we're looking at here. We're looking at the solution curve being tangent. So what I would do here is I'm thinking of integrating both sides of the equation. But let me look at something else first. This one is in terms of x, 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 and this one is in terms of y. The reason why that matters is, if I read down the column here, do you see how all of those slopes are changing? That means that the x value is not driving the slope. In fact, if I read across all the rows, for any given row, the slopes are the same, which means that the y value is driving the slope. So right now, the answer has to be e. And for all of those who want to see that algebraically, let's do some separate, integrate, solve. I end up with dy dx equals 1 plus y squared. So to separate, I'm going to divide by 1 plus y squared and multiply by dx. Integrate both sides, I get the arctan of y equals x plus c. Then I have to take the tangent of both sides of the equation, and I'll end up with y equals the tangent of x plus c. So this is a tangent function, which is what this solution curve told me it would be.